Hello and welcome sa ating first video sa Math 22 series. Our topic for today is integration by parts. So let's recall its definition. Let f of x and g of x be differentiable functions. If u is equal to f of x, du is equal to f prime of x dx, dv is equal to g prime of x dx, and v is equal to gx, then by integration by parts, or IBP, we get the following formulas. The integral of u dv is equal to uv minus the integral of v du, and the integral from a to b of u dv is equal to uv minus the integral from a to b of v du. So how do we derive this formula? So we have f of x and g of x be differentiable functions. Then, by the product rule of differentiation, we have that the derivative of f of x and g of x is equal to f prime of x times g of x plus f of x times g prime of x. So if we arrange this, f of x times g prime of x is equal to the derivative of f of x, g of x minus f prime of x times g of x. If we now integrate both sides with respect to x, we have that the integral of f of x, g prime of x dx is equal to the integral of the derivative of f of x times g of x minus f prime of x times g of x dx. And if we simplify the right-hand side of the equation, we get f of x times g of x is equal to integral of g of x times f prime of x dx. If we now substitute these values to u is equal to f of x, du is equal to f prime of x dx, v is equal to g of x, and dv is equal to g prime of x dx, we get the following formula. Integral of u dv is equal to uv minus the integral of v du, which is the IDP. Note that this proof also applies when applying the second fundamental theorem of calculus after integrating both sides, meaning that this proof can also work sa ating definite integrals. Notes in doing IDP. Remember LIATE? What does LIATE mean? LIATE is a mnemonic which helps people in knowing what u to use in performing IDP. The highest priority is logarithmic functions. Next is inverse trigonometric functions, followed by algebraic functions, then trigonometric functions, and the lowest priority is exponential functions, which forms the word LIATE. Next, it is sometimes useful to let dv equal to dx. An example to this is the integral of ln of x dx. By IDP, let u equal to ln of x, and du equal to 1 over x dx. Let dv equal to dx, and v equal to x. Then, we have that the integral of ln of x dx be equal to x times ln of x minus the integral of x over x dx. Cancelling out x over x, we get the x ln of x minus x plus c. When IVP becomes repetitive, we have to try other methods. An example to this is the integral of secant cube x dx. By IVP, let u be equal to secant x and dv equal to secant squared x dx. We get that du is equal to secant x tangent x dx, and v be equal to tangent of x. Then, we get that the integral of secant cube x dx is equal to secant x tangent x minus the integral of secant x tangent squared x dx. So instead of applying IBB again to the integral of secant x tangent squared x dx, we can use trigonometric identities. So ba't di natin gagamitin IBP? Because when we use IBP to this equation, we go back to secant cube x dx. So instead, we use trigonometric identities. So we substitute tan squared x to secant squared x minus 1. In simplifying this, we got that the secant cube x dx is equal to secant x tangent x minus the integral of secant cube x minus secant x dx. Simplifying, we have secant x tangent x minus the integral of secant cube x dx plus the integral of secant x dx. So notice that there is another integral of secant cube x dx. So instead of using IVP, let's manipulate the equation na lang. So we have two integrals of secant cube x dx. So one in the left hand, one in the right hand side of the equation. So we transpose the one on the right hand side to the left one. So from the equation, integral of secant cube x dx equal to secant x tangent x minus integral of secant cube x dx plus the integral of secant x dx, we have 2 times the integral of secant cube x dx equal to secant x tangent x plus ln of the absolute value secant x tangent x. Simplifying the left hand side, we get that the integral of secant cube x dx is equal to secant x tangent x plus ln of the absolute value secant x tangent x all over 2 plus c. So let's have some sample problems. First, we try to evaluate the integral of x squared times sine of x dx. So we use IBP. We let u be equal to x squared and dv be equal to sine of x dx. So we let u be x squared because algebraic functions have a higher priority than trigonometric functions. Always remember LIATE. So A first before D. Now, we have du be equal to 2x dx and v equal to negative cosine x. Then, we have that the integral of x squared sine of x dx is equal to negative x squared cosine x minus the integral of negative 2x cosine x dx. Simplifying this, we get negative x squared cosine x plus 2 times the integral of x cosine x dx. Note that we can again use IBP here. So again, we use IBP. Let u prime be equal to 2x and dv prime be equal to cosine x dx. Again, algebraic functions have a higher priority than trigonometric functions. So we let u prime be equal to 2x. Now we have du prime be equal to 2 dx and v prime be equal to sine x. So we have the integral of x squared sine of x dx is equal to negative x squared cosine x plus 2 times the integral of x cosine x dx. Now, to integrate this by using IBP, we have negative x squared cosine x plus 2 times x sine of x minus the integral of sine of x dx. Again, we integrate this and we get negative x squared cosine x plus 2 times x sine of x minus negative cosine x plus c. Simplifying, we get negative x squared cosine x plus 2x sine x plus 2 cosine x plus c. So let's have our next problem. Let's try to evaluate the integral from 0 to 1 of x arctan x squared dx. So again, use IBP. Let u be equal to arctan x squared and dv be equal to x dx. Remember that the inverse trigonometric functions have a higher priority than algebraic functions. That's why we have arctan x squared as our u. Now, we have du equal to 2x over x to the fourth plus 1 dx and v be equal to x squared over 2. Then, we have the integral from 0 to 1 of x arctan x squared dx is equal to x squared over 2 times arctan x squared evaluated from 0 to 1 minus the integral from 0 to 1 of x cubed over x to the fourth plus 1 dx. Evaluating this integral, we get x squared over 2 arctan x squared evaluated from 0 to 1 minus 1/4 ln of absolute value x to the fourth plus 1 evaluated from 0 to 1. Now, substituting this, we get 1/2 times 1 squared times arctan 1 squared minus 0 squared times arctan 0 squared minus 1/4 times ln of the absolute value 1 to the fourth plus 1 minus ln of the absolute value 0 to the fourth plus 1. Now, simplifying this, we get 1/2 times pi over 4 minus 0 minus 1/4 times ln of 2 minus ln of 1. Again, simplifying this, we get pi over 8 minus ln of 2 over 4. So here we have a challenge. The substitution method used the integral from 0 to 1 of x cubed all over x to the fourth plus 1 dx was not explicitly shown here. You can figure out what u was used to solve this integral. Now let's try to evaluate this integral. So medyo mahaba yung integral na to. So first, let's try to manipulate an expression inside the integral before we apply integration techniques. So ito yung equation natin at ang unang gagawin natin is try to cancel out yung pwede natin i-cancel out. So sa second and third terms, pwede natin i-cancel out yung x. So magiging ganito siya ang equation. Next, makita natin na common ang e to the x at ang ln of x sa second and third terms. So we take them out and the second and third terms becomes like this. But wait, saan galing yung ln e to the x? Ang ln e to the x is actually yung x natin because yung x is equal to ln of e to the x. So further simplifying this equation, we have the integral of e to the x times ln of e to the x times ln of x all over x plus e to the x times ln of x times ln of e to the x times ln of x dx. So makita natin na common ang ln of e to the x times ln of x sa dalawang terms. So we take them out ulit. Now we have the integral of ln of e to the x times ln of x times e to the x over x plus e to the x times ln of x dx. So now let's have our u be equal to e to the x times ln of x and our du be equal to e to the x over x plus e to the x ln x dx. So, ang equation natin na to ay magiging equal to the integral of ln u du. Ngayon, pwede na natin gamitin ang IDP. So by IDP, let u prime be equal to ln of u and dv be equal to du. Therefore, ang du prime natin is equal to 1 over u du at ang v is equal to u. Therefore, ang integral of ln u du is equal to u times ln u minus the integral of u over u du. So we cancel out yung u over u. Now we have u times ln u minus u plus c. Simplifying this, we have u times ln u minus 1 plus c. Ngayon, substitute natin. And we have e to the x times ln of x times ln of e to the x times ln of x minus 1 plus c. Hope everyone learned a lot sa ating topic today, which is integration by parts. Ngayon, thank you sa pakikinig and hope to see you another time. Thank you.